Let us try an example to calculate the binomial distributions. The table here shows the probability of distributions of the discrete random variable x. The x here is x2, 3, 4, 5, 6, and 7. Their respective probability is indicated here. The question asks us to state the probability when x is equals to 5. From the table here, we know that px equals to 5 will be equals to 0.19. Next, the question asks us to calculate the p when x is equal and more than 3. For that, we are looking into this table here. The px equals and more than 3 will be the summations of all the value here, which will be equals to 0.93. If we need to calculate the px less than 6, in this case, 6 is not counted. That means we are looking into the probability here in the summations, which will be equals to 0.83. Let us try another example. The question asks us to compute the probability of obtaining at least 2 6 in rolling a fair dice 4 times. In another word, you are rolling a fair dice for 4 times. You would like the 6 to appear at least 2 times. The possible outcome of rolling the fair dice for 4 times, it will be none of them are getting 6, or 6 appear 1 time, 2 times, 3 times, and 4 times. So this gives a typical normal distributions conditions. Now you are interested with obtaining the 6 out of the rolling the fair dice. The successful p will be equals to 1 out of 6, and which is unsuccessful, it will be 5 out of 6. A total of 4 times the dice is being rolled. You want at least 2 times the 6 is obtained. That means you are looking into P2, P3, and P4. Use the equations given here. The P2, P3, and P4 are computed here. Summations of all, you will get 0.132. That means you have 13.2% of the chances of getting at least 2 6 out of 4 times rolling the fair dice. Next, we try another example. Now you roll the dice for 9 times. Find the probability that you are getting 4 for 3 times or less than 4 times. When you roll a fair dice to obtain 4, the probability of successful, it will be 1 out of 6, and unsuccessful will be 5 out of 6. You want to obtain 3 times successful, obtaining 4. Adopted these equations. Substitute the relevant value. You will get 13.something% of the likelihood of obtaining that. Now you want to have less than 4 times obtaining number 4 out of 9 times rolling the fair dice. You are looking for 0 time, 1 time, 2 time, and 3 time. As you are interested with less than 4 times, that means 4 times is not counted. Again, use these equations. Substitute the relevant value for 0 time, 1 time, 2 time, and 3 time. Sum everything up. you will get 0.9520. Next, we try another example. A machine is producing a large number of boats automatically. In the box of this boat, 95% are within the allowable tolerance value with respect to the diameter. The remainder will be outside the diameter tolerance value. 7 boats are drawn at random from the box. You are asked to determine the probability of 2 and more than 2 out of the 7 boxes are out of the diameter tolerance value. Now you are interested with those which is not acceptable. You will adopt your P equals to 5%. Q will be 95%. You want 2 of the boats are unacceptable. Use the equations of the binomial. You will get the answer of 0.0406. Next, you will like it out of the 7 boats, more than 2 are unacceptable. In another word, you need 3, 4, 5, 6 and 7 boats are unacceptable. This can be calculated by summing up the P, 3, 4, 5, 6 and 7. Alternatively, you can use the 1 minus P0, 1 and 2. That means you discard the probability that you are not interested from the probability. Use the equations of the binomial distributions. Substitute the relevant value. Solve the questions. You will get the value of 0.00375. Here is another example for the binomial distributions. A package containing 50 similar components and 4 have been damaged during the transit. If 6 components are drawn at random from the content of the package, determine the probability that in this sample, 1 and less than 3 are damaged. You are interested with the damage conditions. So the P will represent the probability of damage, which is equals to 4 out of 50, 0.08. And the Q will be equals to 1 minus 0.08, which is equals to 0.92. The probability of 1 damage is obtained from these equations, which is equals to 0.3164. Next, you are asked to determine less than 3 are damaged. That means you need to sum the probability of no damage, 1 damage and 2 damage. Use the equations of the binomial distributions. You will get the value of 0.9915.